Okay, in this section we are looking at trends in the periodic table. So now we know about the periodic table, and now we're looking at trends in the periodic table. So the first trend we're going to look at is reactivity of the outermost electrons. The outermost electrons are called valence electrons. And a valence electron is an electron in the outermost occupied energy level of an atom. And many of the properties of elements are determined by the arrangement of the electrons in the outermost energy level. Atoms in the same group have the same number of valence electrons. And as a result, the same group tend to react in the same way. So we have looked at the periodic table and organizing it, and we know, for example, the alkali metals, the first column, minus hydrogen, they all have one valence electron. The alkaline earth metals have two. And column 13 has 3, column 14 has 4, column 15 has 5, column 16 has 6, column 17 has 7, column 18 has 8 except for helium with 2, but we know that's a full shell. So it's a pattern of the periodic table. So during a chemical reaction, one atom can join with another atom by gaining, losing, or sharing valence electrons. And we will see that in our next lesson on bonding. The noble gases are non-reactive because their atoms do not gain, lose, or share electrons. The outer energy level for the noble gases is full and therefore provides chemical stability. So these elements do not react easily with other elements. Atoms of elements other than noble gases can achieve a full outer energy level and therefore more stability by gaining, losing, or sharing valence electrons to have a full set of electrons. So we will see that in the next chapter. Another trend on the periodic table is, actually let's go back one moment to filling outer energy levels, something else I'd like to mention. As we go across the periodic table, we can see that we add one electron to the valence shell. So we talked about the fact that they all have the same amount, but as we go across, we're adding one electron. So as we said, this has 1, and then 2, and then 3, and then 4, all the way until we get a full shell with 8, okay? So it's important to note that that is a trend on the periodic table. As you go from left to right, one valence electron is added to the shell. Is added to the valence shell. As we go down the periodic table, we add another valence shell. So from top to bottom, a shell is added, or energy level. So we have 1 here in the first row. Going down, we have 2 and then 3. And that's what the number on the side actually corresponds to, is how many valence shells there are. Okay, so now let's relate that to reactivity. So as we said, atom size increases down a group. By adding the shell, you're adding a shell, it's getting bigger. Across a period, atom size decreases. Reasoning for that? Oh, from right to left. Yeah, from right to left. Oh, according to that, actually, sorry guys. No, it's not. We're talking about the wrong direction here. I was in my mind. Okay, so Going down a group, you're adding a shell, so the atom size increases, and then going from right, this is the right side, to left, okay, the atom size does increase, so it is getting bigger going this way. Okay, so it increases going down and from right to left on the periodic table. Now, the farther the valence electrons are from the nucleus, the more easily they can be lost, and that makes them more reactive. So as we go down the periodic table, reactivity increases because that valence electron is so far away from the protons in the nucleus, because that's what's causing an attraction. The electrons are attracted to the protons in the nucleus. So every time you add a shell, excuse me, you add a shell, it's like adding a football field of distance, relatively speaking. So it's pretty far. So that attraction is lost, and it makes the atom far more reactive as you go down the periodic table. So that is the end of trends in the periodic table. You can refer to the LMS for the questions that you need to do, not the questions at the bottom of this page. Okay? Have a great day. Bye.